spectrum. Someone challenged me and said, well, look, if you clearly you're not a fan of solid, what would you replace it with? And that led me to, is there? Are there a set of principles? Is there a universally applicable set of principles to software? Or is it just such a vast field that doesn't make any sense?
From Toro Cloud, this is the Coding Over Cocktails podcast, a free pool of thoughts and ideas from IT experts, thought leaders, and authors, sharing their insights and advice for individuals architecting solutions for the ever-changing landscape of enterprise tech, digital transformation, and more. Welcome to episode 67 of the Coding Over Cocktails podcast. My name is Kevin Montalvo. And joining us from Sydney, Australia is Toro Cloud CEO and founder, David Brown. Good day, David.
Hi there, Kevin.
Hello. All right, let me introduce our guest for today, who helps business and technology leaders find simple, pragmatic solutions to business and technical problems, often using lean and agile techniques. He has 30 years of experience in IT and is a frequent speaker at technology and business conferences worldwide. The originator of Behaviour-Driven Development and Deliberate Discovery, he has published feature articles in numerous software and business applications and contributed to the RSpec book, Behavior-Driven Development, with RSpec, Cucumber, and Friends, and 97 Things Every Programmer Should Know, Collective Wisdom from the Experts. Joining us today for a round of cocktails is Daniel Terhorst-North. Hi, Dan. Welcome to the show.
Hello. Thank you very much for having me. By the joy of time zones, it is morning here, so unfortunately I'll be doing the coding over. When I heard coding over cocktails, I was thinking, is that like one of the fifth agile value?
New manifest.
Whilst we value cocktails.
Well, Australian company, it's Toro's manifest. We always kick off. Well, we always end the week with beer o'clock. It's a tradition. So, yeah, we don't want to promote alcoholism. I can't wrap my head around it. But yeah, there is a bit of an ongoing theme there, and of course, all our product names are after cocktails as well. So. We have Italian cocktails as all our product names. But look, Dan, I want to start off with solid. Now, you have a problem with solid, which is interesting. So I think we should first all cover off what is solid. So the solid principles were introduced by Michael Feathers, who built upon the work of Robert Martin in his paper, Design Principles and Design Patterns, published back in 2000. Now, those solid principles have served us well for over 20 years in terms of object-oriented programming. You are now challenging these principles. Before we get into your alternative, maybe you can run us through what is solid and what's your problem with it.
So the phrase served us well is an interesting one. They've been around for a long time, certainly. As you said, I've been writing software for 30 years. As a full-time hands-on programmer for the first 20 of those, for the last 10 or so, I've been a consultant. So I'm a cause of programming in other people. I still code when I can. I love programming. These days, I tend to do a lot more looking at reviewing code, looking at programming strategy, architecture strategy, that kind of thing. So helping teams write better software. So solid's an interesting. I think of solid as a useful historical artifact. Okay. When Robert Martin was describing all these principles, he was collecting things. He wasn't just sitting there and making pronouncements. These are things that he'd seen in the wild, and he thought they were useful things to bring together. So there was a good intent behind it. But some things stand the test of time and some things don't. And test-driven development, we're going to talk about later, I came across that over 20 years ago. It was decades old by the time I came across it. It's still completely relevant today. It's one of the most useful software design techniques I've ever encountered. Solid, not so much. So if you look at each of the 5 principles, you can see, and this is what I did. I wrote an article before any of the CUPID work. I wrote an article kind of deconstructing, if you like, just solid. And solid is only 5 principles. Now, there are over 100 of these things in his books. And as you say, Mike Feathers happened to notice that the first 5, if you change the order a bit, you could get this acronym SOLID. You could also get Lloyd's and and Doyle's as well. So, I mean, idols. Oh, there you go, idols. So you can look at them as idols, and perhaps that makes me an iconoclast, I don't know. But so the problem I have with them is, let's look at them one by one. A single responsibility principle says code should have one reason to change. That's the technical definition. So, in other words, you shouldn't conflate different aspects of code. You shouldn't have things like business logic in with view logic, or data access logic in with business logic. And that kind of makes sense, right? You think, that seems like a pretty good rule for life, right? And it kind of makes sense in an age when making change to any code was a high transaction cost activity. So I was working on big C++ systems, multi-million lines of C++ systems in the 90s. I wrote a Europe-wide telecom billing platform, which was fun, lots of multi-currency and fun edge cases, like you had to have one bill per customer, but one of the customers was First Telecom, which itself was a reseller, and so it might have tens of millions of call records in a month. And the original system wasn't designed for that. So I was working on big systems, and especially C++ it's become a much bigger, more complicated language. At that time, it was a pretty reasonable language for doing those kind of systems. This is before Java. And so you'd make your change in your code, and compiling was pretty quick. I could write some C++ code and then run make, and then the compiling stage was a few minutes. There's then a stage called linking, and linking is where a linker resolves all of the various bits of your code and makes sure they all connect to each other. That could take literally hours. So in other words, a one-line change you could have a multi-hour build. Not building and running tests. We weren't doing automated testing much then. Just getting a binary that you can run was a multi-hour endeavor. And when the transaction cost is high, what you tend to do is do more work. So you make bigger changes, because if the cost of a change is high, then you shove in a load of stuff. You don't want to keep doing that every few lines of code. And so that meant that you then have an exponentially higher likelihood of introducing bugs. So this is the context you're working in. And so what they're saying is, look, if you're doing changes to business logic, for crying out loud, don't make changes to the view at the same time. Don't put them in the same code, because that's just going to be a nightmare. If you play that forward to now, we have like the equivalent language to something like C++, which is your business systems language, is Java or C#, or maybe Go sometimes these days. Rust is coming up. But like for a language like Java or C#, I'm in my IDE, I'm typing, the program is compiling behind my fingertips in real time. I've got hot reloading of apps, right? So my transaction cost for making a change is nil. So that's the first change. The second change is that code itself is a lot more malleable. And I think Java was the language that made this mainstream. Smalltalk is where it started, with this idea of refactoring. So if I'm writing C or C++, it's kind of like bricklaying, right? So you write a file, something.c, and then you're done with that file, and you get the next file, something.c or something.cpp or whatever it is. And you write the files and you park them, okay? And so you wouldn't generally go back and make a change to a file. Or if you did, you were making a change within that file. And so the prevalent version control system, for instance, CVS at the time, if you renamed a file, you lost all the history, because the history was file-based. So if you renamed a file in CVS, you just lost all of its change history. And that wasn't a bug in CVS. That's just like a consequence of how uncommon that action was. And now Java comes along, and Java couples the name of a class to the name of a file, and the name of a package to an entire directory structure, right? So now suddenly when you have refactoring tools in Java, changing file names and changing entire directory hierarchies is common. It becomes a single keystroke, yeah? And so suddenly tools like CVS are breaking, and that's where Subversion came from. It was the next generation of CVS that was refactoring aware. That was the big thing it did, is a change. The change was a change of a bunch of files was atomic instead of per file. And we play that forward, and we get tools like Git. So the mindset that code would only change in one place just became nonsense. Code changes all over the place. And also the tools for navigating code became much, much richer. Right, so instead of using VI or Emacs or whatever you're using for editing your C++ code, which had pretty good code navigation, there's a brilliant thing called C tags that they would both use that would allow you to navigate code. But like in IntelliJ, I can just do find usages across a code base with hundreds of thousands or millions of files in it, and it goes, yeah, here they are. Right, here they are, and I can guarantee there's no false positives because I can build a deterministic AST from my code. Right, so. So there's the whole context. So now let's take a look at single responsibility. When I first start writing a new piece of code in some language, in Python, in Rust, in Go, in whatever it is, why do I want an arbitrary separation of all the bits that are changing together because they're in my head right now? You know, the UI doesn't change on its own apart from for trivial UI changes. If you're going to make that button blue, that's a UI change, right? Usually a UI changes because I've added some more information or I've changed the information. And I changed the information in the business layer. So that means that changed in correspondence with that. And that probably changed because there was some data change or some event change. And so actually all these things do change together. And so now what I've got is a bookkeeping exercise, right, where I have to go, you know, I've got the guest to set, to get to set, to get to set, to get to set. If you ever did any enterprise Java back in the day, most of your life was copying and pasting code between getters and setters. Right? This is madness. Except then you get Rails, right? And Rails has the same thing. You have models and views and controllers and in separate directories, because that's what single responsibility says, is that they have to, it doesn't say they have to live in separate places, but that's what software craftsmen do, is they take these things to the nth degree. And now we're stuck with this model where in order to make a change to code, I have to go ferreting around in all different files, right? I've never done that. I've managed to get by 30 years without using single responsibility principle. So it's, you know, again, I describe it as neither necessary nor sufficient. If you do it, I mean, maybe. The other thing, and I'll shut up because I know we've got a lot more, we're only on S. The other thing to bear in mind is you can think of it as a premature optimization of code structure. So if I am duty bound, honor bound to separate my code into areas that only have one reason to change, that means that I'm not allowing myself other seams. Right. So for instance, what I might have is a bunch of code that's to do with billing, and a bunch of code that's to do with customer management, and a bunch of code that's to do with with buying or something, whatever my product is, a bunch of things that are to do with search. And those areas of functionality, that might be a much more sensible way to arrange my code. But I don't get to do that because I'm already in models and views and controllers is my top level view of the world.
Well, so, I might ask you, you came up with a new acronym called CUPID as your alternative to SOLID. So as you're going through these SOLID principles and you're talking about the single responsibility principle of SOLID at the moment, maybe you can run us through the CUPID alternative and how it resolves these issues you have with SOLID.
So that's a great question. I'm going to counter with something a little different. So I thought, so originally, here's the backstory. I just poked the bear of SOLID in a fun talk about 5 years ago. It was literally a 5-minute talk in a pub with alcohol. Again, you know, drink aware, folks. And there were a whole series of these Ignite fun, silly talks, and it was a post-conference event. And I thought I'd poke at SOLID, and I did. It was a 5-minute talk, so for each of the 5 principles, I gave 15 seconds describing it, 15 seconds describing why I don't like it, and 15 seconds saying what I would do instead. And thinking I would have exactly the answer to your question. And as I wrote the talk, I realized that the thing I would do instead was the same thing every time, which is write simple code. Now, clearly write simple code is itself a bit vague. So I needed to clarify what I meant by simple, and my working definition of simple is it's not about my head. It's code that fits in someone else's head. So someone else, you, Kevin, can come along, see this code and go, yeah, I get what's going on here. And my qualifications for that person's head is that they understand the language, idiomatic code in that style of language. So they don't, they're not going to come. I'm not going to take someone who's never seen Go code before and say, what does this do? So the idea is that someone who's familiar with the language, its ecosystem, its core libraries, its runtime, its build chain, tool chain. So given those things, and also some familiarity with the domain that we're working in. So if you have all those things and you can look at some code and it's obvious to you, then that's simple. If it's not obvious to you, it means that there's some tacit knowledge that's in Kevin's head that's about how this module connects to that other module because you have to know about this other secret module over here. Right? That's now not obvious. So how do we make that tacit knowledge explicit? And it turned out for each of these 5, basically my go-to was write simple code. So some years later, so this is where CUPID came from, someone challenged me and said, well, look, if you clearly you're not a fan of Solid, what would you replace it with? And that led me to, is there? Are there a set of principles? Is there a universally applicable set of principles to software? Or is it just such a vast field that doesn't make any sense? And I got to thinking about it, and I ended up with properties. I said, I wouldn't describe any principles as universal. They're all contextual. But there are properties of code that I think make it joyful to work with, that make coding fun. I've been into code bases. I've been super lucky in my 30 years. I've been into code bases more than once, not often, but more than once, and just smiled. You look at the code and you're like, I get this, and I'm about to have fun. Right, I'm about to make a change here, and I know I'm going to do it confidently. I know I'm going to not mess things up because someone else who came before me put this together in such a way that it just couldn't be more self-explanatory, couldn't be more intention revealing. And it's, oh mate, when you get that, you don't ever want to not have that. And also it makes you super careful. Like when you're in there, I want to leave it like this.
What are these properties of CUPID?
Gorgeous house and then just trash it and then go.
Yeah. They've set a benchmark. So what are the properties of those? Those 5 properties of CUPID?
Well, and so this is what, so my counter is this: is that I don't have a one-to-one correspondence with Solid because I think individually each of them is silly. Each of them is again neither necessary nor sufficient. Useful at a time, right? In the mid-90s, which is a generation ago. They were good sound advice, but they haven't aged well. So what would I describe instead? So I describe properties of code. So very briefly, CUPID is a backronym. So I started with a word and then added and then assigned properties, which is great fun because and it was deliberate as well. CUPID is like it's the god of love and it's about joy and romance and stuff, and it's like the opposite of the kind of bro culture around software craftsmanship and Solid and all of that. So I wanted something deliberately controversial. And it also means that you get to have candidates. Like there's loads of things that begin with C. I'm going to write, actually I've got in my head, I'm going to write a series of articles of the runners-up. Like there were loads of I, and I ended up with idiomatic, but there were several for I and then what I discovered delightfully as an accidental consequence is that all of the runners-up you can derive from the 5 that made it. So the 5 that made it are kind of foundational. And then anything else you can say, well, because of these things, you're going to necessarily get that. So briefly.
You like Wordle, don't you? You're a huge Wordle.
I'm not. No, I've never played Wordle. I've seen it. I've never been inclined to play Wordle. I have plenty of Wordle on my Twitter on my Twitter timeline, but I don't actually play. C is composable. So this is the idea, the kind of the principle of preferring composition over inheritance. But the idea with all of these properties is it's not at a line of code, just at a line of code level. So the idea is that all of them are fractal. So I want composable code, I want composable functions or methods, I want composable classes or objects, but then I want composable modules. And I want composable subsystems. So when you're designing APIs, there's composability there. When you are thinking about how you're going to build your code, there's composability. So, for instance, one of the aspects of composability is dependencies. Right. So if you give me a lovely, lovely API and it drags in half the internet through Maven, right, I'm much less likely to use it. So composability requires you to think small, requires you to be very, very discerning about what dependencies you absolutely need and what you can't roll your own. So let's see. U is Unix philosophy, which is do one thing and do it well, which kind of sounds a bit like single responsibility, right? Except very deliberately, the CUPID properties are in the eye of the beholder, right? Beauty is and joy is in the eye of the beholder. So it does one thing for you as a consumer, whereas the solid principles are from the perspective of the code. So it has one reason to change. Yeah. So it may do one thing and have one reason to change, but if from a consumer perspective, that lump of business logic is no use without the view on it and without the data on it. So that is do one thing. So with the component piece, with the be composable and do one thing, you've basically got Unix. So all of the Unix shell commands, the kind of core commands, they're all about composability. And they're all about doing one thing well. So cat gives me contents of files, wget or curl gives me contents of web pages, etc. And then from that content, I can then filter that content using grep. I can then transform that content using sed or awk. I can then so you can and then I can filter out what's left using unique, for instance, or sort. So just having really simple primitives for text processing, I can build very sophisticated pipelines because everything is composable and each thing does one thing really comprehensively. So that's the U. P is about predictability. So predictable is, the way I'm describing it is it's a generalization of testable. Right, so Mike Feathers, his lovely book, Working Effectively with Legacy Code, he describes legacy as anything without tests. Right, so I went broader than that because I've seen legacy code bases without tests that were joyful, that were brilliant to work in, and I've also seen entirely test-driven code bases that were an absolute rat's nest, and I wouldn't want to do work in them. So again, having full test coverage, which we'll get onto later, is neither necessary nor sufficient. But yeah, so predictable is I know what it does. I can tell by looking at it what it does. So it's about intention revealing. It's about it does what you think it will do. So code that does what you think it will do. And also that it's easy to determine that it does what you think it will do. And that's not necessarily with automated tests. It may be through some kind of checker. It may be by running it. It may be by putting by looking at it. But if I can make code that is easy to instrument, right, that has its own telemetry, that tells me when things are wrong, that fails in a well-known way. So predictable code isn't just about that it follows the happy path every time. It's that when it fails, it fails in well-known ways, and we often don't think about that. So does it fail silently? Does it fail silently and corrupt data? Does it fail catastrophically? Right? And I need to know this, and this allows me then to use your API. So that's the P. I is idiomatic, and this is a really big deal. Idiomatic means you write code like everyone else would write code. So it's a lot about egoless programming, right? If I go into a code base and I can see that this is David's code and I can see that this is Kevin's code, then props to you for having your own style, but it means that now I've got more cognitive load. I've got to not only think about the pricing algorithm problem I'm trying to solve, I've also got to think about how David would have coded this and where he might have put this and his weird naming convention for stuff and his penchant for a different testing library from everyone else, right? And all those lovely idiomatic, all those lovely personal quirks. So idiomatic code says, write code like everyone else. If the language itself has an idiomatic style, Clojure is a massively idiomatic language. The Clojurians, they all write code that looks the same. They all write this lovely, lispy style of code. And you can tell when someone's new to Clojure because they're trying to write imperative kind of procedural code in a lovely, functional, listy language. And it takes a while to get there. Likewise, Go has Go format, which takes all of your syntax discussions off the table. It also has a massive standard library where everything looks the same, right? And I hate their naming conventions. Something that does reading and writing is called a reader writer. You're like, really? That's the best you could do? And something that does reading and writing and printing, guess what that's called, right?
Write a print.
But then, how about that? But then what happens is that as you look through the core library, if you've done anything with the HTTP library, you've written some HTTP code, and then you go to use the FTP library, man, it's familiar. It's like I've already been here, because whoever designed the FTP library made it look just the same as the HTTP library. And all the errors fail in the same way. And then you look at the SMTP library, and guess what, right? Any network protocol libraries have all been designed with a similar flavor. And so what they have, they bake that idiomaticity. Anyway, they bake that into the language and into all of the example code. And along with that, you get this effective Go, which is a beautiful document that says, here's how we write Go around here. I'm not advocating for Go. I think it's a really ugly language. It's very good for a small subset of things. But boy, are they idiomatic, right? Because they know how many developer hours, days, millennia have been lost to pointless arguments about style, right? And how many really subtle bugs have come in because I thought I was in some of Kevin's code and actually I'm in some of David's code and he does error handling differently and my thing just silently failed, right? So then it's layered, right? So you have idiomatic, what the community does, then idiomatic, what we do around here, like in this organization, and then idiomatic, how our team writes code. And if you kind of layer those things on, it's pretty hard to write code that doesn't look like the other kids, right? But if you don't set those standards, if you don't make those, set those lines in the sand when you start, you just end up with 10 different styles of code. And it makes change much harder and much less joyful. D, the last one, domain-based, which is, and again, this goes right back to the S conversation we were having earlier, single responsibility conversation. So I'm a massive fan of domain-driven design. Domain-driven design was one of the core ingredients to BDD back in the day, in the 2003 or something. And I'm a huge fan of Eric Evans. I think he's a giant in our industry. So domain-driven design is the idea that writing software to solve business problems isn't the point. Right? Understanding the domain and solving problems in that domain is the point, and writing software is like a useful byproduct of that. Right? So, I'm trying to understand. So his background is shipping, so logistics. And so what he does is he spends ages and ages working with people, understanding what they mean by a manifest, what they mean by moving cargo around, what they mean by bonded warehouse, and all the business rules that flow from that, and how we do work. And just software just kind of seems to appear while he's having these conversations, right? But the names in the code represent things like, if you've got a bonded warehouse, there'll be a bonded warehouse thing in the code. You can't not know that this code is about bonded warehouses, or this code is about derivative pricing, or this code is about patient healthcare management, because it just says it. You haven't got int I, you've got int patient ID or something, and you can't not know. And so anyway, strong domain naming is just, again, another way of reducing cognitive load. But then what I talk about is domain structure as well. And this goes right back to things like Rails and all these kind of frameworks that have like views here, controllers here, models here, helpers here, managers here, whatever it is. And like, I don't care about all that. I mean, I know I'll need those things, but what I want at the top level is patient management, right? Order booking. Like, I want my broad bounded context, my broad subdomains at the top of my code base, and within those, then the subdomains in there. And yeah, there'll be models and views and controllers in there, but I'm an adult and I can find them. So I want to see the framework. I want to see the solution.
Dan, you briefly mentioned there that BDD, which is behavior-driven development, when you're talking about domain-driven design, you developed behavior-driven development as a response to the confusion and misunderstandings, in your own words, from various agile processes such as test-driven development. So, Run, I'd like you to dive into, if you may, behavior-driven development. What does that mean, and what was it developed in response to?
So it's interesting. I think with with a lot of these techniques, particularly with, and TDD is a really good example. There are several others as well, where you get I think a genuinely game-changing technique that gets let down by a poor name. Okay, Kent Beck is an amazing programmer. He really is an amazing programmer. He isn't great at naming things, or rather, there are better names. And so test-driven development suggests that there's tests, right? And he said, actually, when he describes it, he says, right, we're going to start with a test. In fact, we're going to start with a failing test. And I started doing this. I picked this up around late 90s again, so 20-something years ago. And I was fascinated by it. So you write code for code that doesn't exist yet. So what we do, it's like a model client. You're writing a model client for some code that doesn't exist. Let's take an example. We're going to go and get we're going to go and get some code out of a database. Okay. So ready? Sleeves up. We're going to go get some code out of a database. Let's write an API for that. So let's see. The API could be connect to database, run a query, close a connection. Right. That's the three things we need to do. So we go, okay, and then we go, right. So let's write a client for that. And our client would be connect to database, run a query, close a connection. And you look at me and you go, you know what's going to happen here, Daniel, don't you? Like, what's that? They're going to forget to close the connection. Oh, yeah, no, you're right. Okay, try, open database, run query, finally close connection. Okay, yeah, that's okay, I'm happy with that, fine. What about if the connect fails? Oh, yeah, let's think about what kind of failure we're going to have. Okay, and so what we're doing is we're now designing the API. Right, we're designing the API, and then you look at me and you go, who else in our world is ever going to do try finally? And we look at each other and we go like, no one. Right, so what if we put that behind the API? And what if we just had run query as the entire API? And in our implementation of run query, we're going to do that try finally thing. So it's a bit more work for us, much easier to use. So we've just had a design discussion in writing a model client. We've taken a model client from 3 lines of code and a complicated construct to 1 line. Right? Go us. Because hopefully many more people are going to use our code than they're going to write it in the first place. Yeah. So what we've just done is simplified the API. That's test-driven development. Did you hear me use the word test in there at all? No, because I'm writing a model client. I'm not writing a test. Right? Now, it turns out that if I use this model client to then exercise the thing I built, and I can maybe put some assertions in there about how I think it should behave, then it becomes a test. So this is the linguistic shift, is that your model clients, your code examples, become a test after they were useful. Right? I wrote the code to design the API. That was the value. I then get this handy byproduct that I can run it in the future and see that it still works. Score. The problem is all the spotlight went on the second bit and not on the first bit, including in Kent's head where he talks about it's a test. It's not a test, it's a model client. Even if you're Kent Beck, you're still writing a model client, right? And so as an experiment, this is 2003, I remember vividly, I remember the team I was on, and I was trying to pitch TDD to them. I was like, it's the best way to write software, it's brilliant, you end up with really good design, I've been doing it for years, it's awesome. And they're like, no, we're programmers, we don't write tests, we have testers to write tests. And this is very much the culture of, testers are cheap programmers, or, they're the people who aren't good enough to be programmers, that kind of mindset. And I was like, but it's not really a test. Well, you called it a test. It's called test-driven development. You said we're going to write a test. It's like, oh, crap. How else can I do this? Meanwhile, the testers got wind of this, and they're like, are you getting the programmers to write tests? I was like, kinda. And they said, that's our job. And it was partly like a fear of losing their job, but it was also, we know these programmers, and they're rubbish at writing tests, let me tell you. And so I thought, well, how can I describe this differently? And so I said, right, I'm not going to use the word test. I'm going to talk about behavior. I'm going to say we are going to describe the behavior of the code before we write the code. It's like in a spec. You'd write a functional spec, right? And in the functional spec, you say, this is our expected inputs and outputs. They say yes. So we're going to call it specification. So we're going to write an executable specification. And that executable specification will document the expected behavior of our code. right? So, and here this became the sell. If you do this, David, you don't have to write a functional spec. Right? Shut up and take my money. Either do TDD with Dan, or you can write functional spec. Where's Dan? And so now people start, and then suddenly all the adoption questions went away. Yeah, let's do it, because what we're doing, we're writing behavior ahead of time. And then, oh, by the way, kids, as a cool side effect, these things make pretty handy tests. Yeah. So that was where BDD came from. It was an attempt to reframe TDD. So I don't have a beef with TDD. I love TDD. I still think it's the most powerful model I've ever come across, technique I've ever come across for design in the small. It doesn't give you design in the large. You still need to have a picture of your architecture that you're growing into. You need to make some decisions about, are we event-driven? Are we 3-tier? Are we client-server? Are we message-based? What sort of thing are we building? But in the small, when I'm building this piece of it, TDD is absolutely a brilliant way to come up with good design, especially with pair programming. They work so well together. So you and I sit down, and we had that conversation in real time about that database API, and we smashed it. Right? We put all the error handling where it should be. Now that it's a single method call, by the way, and we're owning the try finally, we can also do things like connection pooling. That's cool. Right, we just got that for free, right? Because we put that behind the API, and all of that came out of, will anyone else ever do try finally? And you looked at me and you went, no, Dan, they won't. Let's do that for them. So it's a brilliant design technique. So there we are then with BDD. And then, and I remember this vividly as well, in 2004, I was talking to a business analyst buddy at ThoughtWorks called Chris Matz, and he said, oh, what's this BDD thing then? Because I've been hearing this, going around ThoughtWorks about BDD. And I said, oh, basically you describe the behavior you want in terms of an automated way, and then you implement the behavior, and then you check that what you got is what you wanted. And he looked at me and he said, you just described business analysis. What do you mean? He said, well, business analysis, you describe what you want, you write some software, and then you check that it does what you're supposed to. And we both just went, right. Maybe this works at multiple levels, right? Maybe we could use this BDD model to describe behavior. And there was an index card kind of template going around ThoughtWorks at the time. There's a lovely guy, Ivan Moore. And what he would write on an index card, you'd write your stories on an index card because we do old school. And if it doesn't fit on like a 5x3 inch index card, then it's too big. You need to write less words. Yeah. Write fewer words. So, and on the back of the index card, he wrote a line down it, and in 2 headings, I do this, this happens. Right? I do this, this happens. And that was his acceptance test. Right? And so you go, I do this, log in with a password, this happens. I see the landing page. Bad password, this happens. Error message. Bad password 3 times, this happens. Locked out. Right? So really simple way to capture acceptance criteria. So Chris looks at this and he goes, yeah, that's not going to work. So what do you mean? He said, well, I do this. He said, any number of things could happen. Depends on the context, doesn't it? Said, let's say you log in with a correct password, yeah, and the system's down. Do you get in? No. You get a 501, don't you? Nothing to do with you. I was like, oh, whoa, you're right. And so he added a 3rd column at the beginning, which is context. And that's where given, when, then came from. So given some context, when I do this, then this happens. And so now we had this like really lightweight template, if you like, for capturing those examples. So now at a code level, we could, and I still to this day, 20 odd years later, I still to this day when I'm writing, so I do, or if I write any BDD at all these days, I use things like PyTest or JUnit, real simple, what we would think of as unit testing frameworks. There's very few times I will reach for something like Cucumber. It has its place. The plain text runners have their place, but it's much, much smaller space than you'd think. Anyway, that's a whole other conversation. So I still structure, given, when, then. So I go hash given, hash then, hash when, hash then, or / given, / hash when, / then. And then I start writing my example, my model client. And I iterate from there. And so Chris and I kind of buddied up And we had this thing called behavior-driven development. We started talking about it at conferences. So my beef with TDD has never been with TDD. I love TDD. I heart TDD. I'm not obsessive about it. It has a place. And the other big risk with TDD, I wrote a big article about this last year. I don't write that many articles, but I had a thing going in my head for literally years that finally came out, is that it's still 20-something, 30-something years on, is still nothing to do with testing. Right? And what I mean by that is this. Let's say you and I pair on something and we do TDD and we end up with a bunch of code examples and we say, right, we've got tests now. Now let's look at those tests. Those tests were the smallest number of model clients that triangulated on our answer. So we probably just started with one to get the basic API. And then we're going to try one that's going to test maybe some error conditions or something. And maybe one that's going to put in some bad input. Right, and we go, right, are we confident that what we've built is probably robust? And we go, yeah, I'm down the pub, or out for coffee. Yeah. If you're a tester looking at that, you're just going to break out in hives. That's not tested. No, it's not. It's minimal viable assurance that you probably haven't messed it up too badly, but it's not testing. So I could take that test. I could take one of the tests that puts a value in, and I could write a generative test based on that puts in hundreds of millions of values and just keeps them running all the time. And every now and then it bips because it finds a failure mode. And it turns out that if you have a very, very small negative number close to zero, due to some floating point quirks in the Java library, that it breaks our pricing. Right? Neither of us would ever have thought of that. Luckily, we're just slamming it with random numbers, and one of them broke. When it breaks, we can figure out why, but we're unlikely to break it. Right? That's testing. assuming that it might break.
I'm going to have to cut you short, Dan, because
please do. I'm sorry. I can rattle that stuff forever. I'm so passionate about this.
Well, I think this is our longest podcast, and you warned us beforehand that you you had plenty of material on this subject matter, and you were right, because I haven't even asked you half the questions I had written down to ask you. But I am interested.
I'm happy to come back another time.
I think so. I am interested in one thing before we wrap up. Is what has been the community's response to CUPID and BDD? Did you get a lot of flack? Did you get accolades? What has been the response?
That's a brilliant question. I think with BDD, I was amazed. I was amazed at the adoption of BDD. For me, I never meant it to be a thing, right? It was genuinely a coaching hack. I was convinced that this team would benefit from TDD, and I was convinced that the pushback I was getting about testing was totally irrelevant, but I couldn't convince them it was irrelevant. So I just started over. I said, we're not going to do that thing. We're not going to do TDD. What we're going to do instead is write an executable spec. But then there was a ThoughtWorks. This is back in the early days of ThoughtWorks. We had these things called away days, and the whole company would get together and do stuff and give talks. And I gave a talk about it. And this wonderful lady, Liz Keogh, got very excited about it and said, right, how do I turn this into a thing? And it kind of went sort of viral within ThoughtWorks. People started finding that this technique was a great way for them to introduce TDD as well. And then suddenly the world picked it up, and I had no plan that was going to happen. And then sometime later, in the Ruby community especially, some folks that aren't me, some folks wrote a thing called RSpec, which was like a BDD style, like a given when then structuring for Ruby. And I was writing something in Ruby, and I wanted something at a higher level than RSpec. RSpec's a code level thing, and I wanted like a given when then thing. So I wrote a given when then thing, and I called it RBehave. And then the RSpec folks, which was David Chilimsky, Aslak Halasoy, some other folks, folded that into RSpec, and then Aslak went and basically rewrote it as Cucumber. And this thing just exploded, right? So Cucumber suddenly became, I think, one of the most downloaded software products of all time or something. And so no one knew this was going to happen. And then I think my head finally exploded when it had its own conference.
Wow.
Right, so BDD got its own conference. I was like, wow. CUPID has been much more deliberate. Yeah. I've given keynotes at my own things. And there was a lovely phrase I learned many years ago that I try and live by, which is if you want an idea to travel a long way, don't try and travel with it. And I've never tried to be the BDD person, right? The BDD community is rich, exciting, vibrant, creative, and way, way, way bigger than me. And that delights me. But CUPID is much more deliberate. CUPID is, right, well, look, you know what? I'm going to do something here. I'm going to talk about this thing. I've spoken about it at conferences. I've written this article, which appeared on Hacker News. In fact, the backstory appeared on Hacker News, and then the article appeared on Hacker News. And it's a nice bit of amplification. But then, and this came from totally left field, I discovered I'm in the latest version of the ThoughtWorks Tech Radar. Right, CUPID is now a thing to explore or something. No, it's not adopt. I can't remember what it's called, but like the thing where they're saying we've become aware of this thing, and you might want to have a look at it. And I'm like, wow, that's probably the shortest time from anything certainly I've done to anything that's appeared in the ThoughtWorks Tech Radar. And the feedback I've had from CUPID has been universally positive. There's a bunch of course, solid programmer, craftsman type who are just rattling pitchforks, but they're the same people who rattled pitchforks when I did the talk with the original, poking the bear talk 5 years ago. So I'm kind of over them. But other than that, no, genuine. There's been a lot of love, a lot of positivity, and I'm super excited about CUPID. So yeah, I'm not sure where it goes, but what I did was I unpacked the article. It's a 5,000 word article. I unpacked it onto its own little website called cupid.dev. So if you go to cupid.dev, it lays out all of the properties. And my aspiration at this stage is to start collecting case studies and putting them up on the website as well, so people can see other people using CUPID. And as a tool, as a review construct, as a set of maybe design principles, that kind of thing.
And of your social channels, Dan, is you more active on Twitter, LinkedIn, on the dannorth.net website? Where do our listeners where should they follow you?
So I'm on Twitter far more than I should be. That's my main channel. Like I'm not on Facebook or Instagram or anything. I'm on Twitter a lot. I occasionally go to LinkedIn, but I find LinkedIn tends to be where messages go to die for me. So I think I use LinkedIn as like a big phone book. So Twitter definitely, and dannorth.net is where I publish things. But typically what I'll do is I'll publish something on dannorth.net and then I'll tweet about it, and that's how you find out. Brilliant.
Look, so many interesting insights. We could have gone on for way longer. Congratulations.
I'm so sorry. You just ask good questions and I'm just on a roll.
Congratulations. You just established our longest ever podcast by a good margin, I might say.
Wow. You can just cut me out, right?
Dan, it's been a pleasure having you on the show. Thank you very much.
Thanks very much indeed.
Hey listeners, thank you for joining us in this round of cocktails. Please like and subscribe to check out other episodes of this podcast series. We're also available on your favorite podcast platforms, or you can simply listen in at torocloud.com, where you'll find full episode transcripts and show notes. On behalf of the team here at Toro Cloud, thank you very much for listening to us today. This has been Kevin Montalvo for Coding Over Cocktails. Cheers!